Science 4B, question 7. Okay, so first things first, we've been asked to do a binomial expansion on 16 minus 3x to the power a quarter up to and including x squared. Okay, so first things first, note it is not starting with a 1, so we need to factorise. That's 16 to the quarter brought out 1 minus 3 over 16x to the quarter. Okay, so we have got our x term, including the negative, and we've got our power. So there's our n and our x, and we're ready to apply the expansion. Now, 16 to the quarter, well, what's the fourth root of 16? Well, that's 2. So keep it going. Remember what I've said in previous videos, don't just have it at the front, make it reappear at the end. It needs to be consistent. So you've got 1 plus n x plus n minus 1 over 2 factorial, or 2, x squared. Okay, so I'm not actually going to go straight and multiply this one out because there's quite a bit on the numbers and nothing nice cancelling. So I've got 1 minus 3 over 64x minus, because this next bit is a little bit fiddly, stick it all in your calculator and you get 27 over 8,192x squared. Not the nicest of expansions. Multiply the 2 in and you get 2 minus 3 over 32x minus 27 over 4096x squared. Okay, now because the next part of this question is to do with finding an approximation, I am going to add the valid for at the end. So remember, it's the modulus of x is less than 1. What was our x? 3 over 16x. You don't need the minus, you're putting it inside a modulus. Okay, remember that takes the size but not the sign of the number. So that's the modulus of x is less than 16 over 3. So we just have to be careful. This expansion is only valid as long as x is less than 16 over 3. Okay. Right, now I would like to use a suitable value of x to obtain an approximation for the fourth root of 15.7. Now, if we put that in index form, that's 15.7 to the quarter. Oh, wait, that looks familiar. What value of x will make it work for our expansion? Well, our expansion was 16 minus 3x to the quarter. Oh, look, that pretty much matches. The powers are the same. So what I need to do is make the insides the same. And actually, I can do that in my head, actually. Now, I would like 15.7, that's 0.3 less. I was doing 16 minus 3 lots of something, so x is equal to 0.1. Okay. So, I've got my x, so if you want to solve it manually, of course, what I'm doing is saying 15.7 equals 16 minus 3x and solving it with a bit of rearranging or in your head. Now, quick check, 0.1 is safely less than my 16.3 that I had up here, so I am allowed to use it. And if I put 0.1 into my expansion, I will get an exact estimate, well, an estimate for the fourth root of 15.7. I won't have to do any multiplying. This is the other style of question as compared to question 3, say, where you're given an x, but it will probably be a multiple of what you're looking for. In this case, we don't have to be clever. We can find exactly what we need without any final work. So let's have a quick look. I'm going to put 0.1 into my expansion. So that gives me 2 minus 3 over 32, 0.1. Right, let's just start that line again. I think I keep catching my trackpad on my laptop. That's all that is. So that's 2 minus 3 over 32, 0.1. Minus 27 over 4096 lots of 0.1 squared. So all I've done is that everywhere I had x in my binomial expansion, I've chucked my 0.1, which will make the numbers I need, and to 3 decimal places, 1.991 if you stick it in your calculator. Of course, in an exam, I would then go and check what the 4th root of 15.7 is, and that is a pretty good estimate.